Hi, welcome to this multiple choice question walkthrough looking at balancing using oxidation. So they tell you that iodide ions react with MnO4-, and it gives you the unbalanced equation, and they want the ratio of MnO2 to OH-. Both of these are found over on the right hand side here. So the fact that there's two manganese containing species would suggest that it's going to be a redox equation. So the reason I say that is because manganate 7, that's this one over here, is a commonly known A-level oxidizing agent that most students and candidates will have come across when they've done redox titrations. So that's a strong hint that this is actually a redox reaction. So what will happen is when you balance using oxidation numbers, the desired ratio will fall out of this process naturally. And it's much quicker and more elegant than using the older GCSE method, which is basically going back and forth, which is a bit time consuming. At the end of the day, it's a multiple choice question, 1 mark. You need to find a sort of a slicker, quicker way of doing it. So let's focus on the equation first of all. You assign oxidation numbers to everything, and then what you do is you think about what oxidation numbers change. So having a look, you can see that iodide goes to IO-. This is called the iodate 1 ion. So iodine is -1 there and +1 over here. And manganese is +7 over here and +4 over here. Everything else stays the same. So just focusing on those 4 things. Now you can actually see what's oxidized and what's reduced. So what we're trying to do is work out how many times each half of the equation has to be multiplied up. So how many times does the oxidation have to happen in order for the reduction to be supported? And the reason we have to do that is because you can see the electron numbers being transferred at the moment on balance. But if you double the oxidation number in the reduction, double the number of electrons gained, in the reduction, and treble the number of electrons lost in the oxidation, they both multiply up to 6 as the lowest common multiple. So now what you have to do is apply that to the relevant species. So anything that contains iodine has to be multiplied by 3. Anything containing manganese has to be multiplied by 2. So the last thing to do is to think about the total charges each side. So if you add up the minus charge on the left and the minus charges on the right, you can see still they don't balance. Now this is where the hydroxide will come in. You can change the hydroxide without affecting anything else. You can also see that there's 2 hydrogens in the water on the left hand side and only 1 hydrogen on the right hand side, so you're actually not quite balanced for species yet. You're balanced for electrons, but not for species. Now if you double the hydroxide, that will take care of both of those things. So now you have 2 hydrogens on the left and the right, and you have an extra negative charge on the right, and now the charge is balanced on both sides. So going back to our manganese 4 oxide and our hydroxide, it's a 2-to-2 ratio, which is essentially the same as saying 1-to-1. So that makes it answer C. Okay, thanks for listening. Until next time, see you soon.